All right, here we go, part two for section 1.4. And let's go ahead and change this out. Now let's do a little drawing action. Let's go back to the orange, crazy orange. All right, are we ready? Yes, we're ready. Here we go. Part two, write the equation of a line that's perpendicular to segment AB and going through the point C. So, tell you what, I'm gonna go ahead and label this. This is going to be -5, 0. Now, do we know the slope of this line? That's the first thing I'd be asking myself. So it looks like you're going to go down 1, 2, 3, 4, 5. And you're going to go over 1, 2, 3. So it looks like the slope of this line is rise -5 over run +3. And that means to us that the perpendicular slope is going to be opposite reciprocal. So let's flip the fraction, 3/5 positive. And the point we want it to go through again is -5, 0. So, tell you what, for this method, let's just start with the slope intercept and see how that goes. So we're going to start with y is equal to mx plus b. Plug it in. So the y coordinate is going to be 0. Slope is 3/5 times the x coordinate, which is -5, plus b. Again, don't be nervous with the fractions. It usually works out. Stick this over 1. And let's multiply this. Going across the top, 3 times -5 is -15. 5 times 1 is 5. And let's reduce this to 5 goes in there evenly, -3. So 0 is equal to -3, and bring down your b. So solving for the b, let's do inverse plus the 3 across. So 3 is equal to b. And since we did this way, let's go ahead and do the rewrite. So we got y is equal to, the opposite reciprocal slope we used was 3/5 x, and then we got 3 for the y-intercept. So that is it. And you are done. Hard to check mark. All right, next screen. Determine the equation of a line perpendicular to x equals 3 going through -4 or 5. Now, if you know your equations, you know your lines of slope, the graph actually would be the easiest way to go here. So check us out. Anytime it's just an x equals 3 numbers, remember this is going to be just a plain vertical, because the x equals is the only kind of equation. A vertical line is the only equation that you can't write in slope-intercept form. You can't write with a y. So imagine x equals 3. Imagine going out to +3 on the x-axis, x equals 3, and just drawing a vertical line coming straight down. I mean, that's what you're dealing with. So this is what x equals 3 looks like. And again, it's a vertical line. You can't write in slope-intercept form, and one of the big reasons is because there's no slope. It's undefined slope. So I'll put this right here. You can't put a number on it. Undefined slope. So it'll make the equations definitely more interesting to work with. Let's just stick to the graph. So if that's the line, think about this. If x equals 3, that means the opposite reciprocal slope is going to be perfectly horizontal. So imagine going straight through there like that. So that means, well, let's go ahead and write it like that. Let's go ahead and do this. Undefined slope, which means your reciprocal slope is going to be 0. So quick rehash. Horizontal lines always have a slope of 0. Vertical lines always have slope of undefined, no number. Okay? So anytime you'll do opposite reciprocals, you're just going to bounce back and forth between these two. So using, let's use point slope this time. So we're going to use opposite reciprocal slope, 0. And then I want it to go through negative 4 or 5. All right, here we go. So y minus the y coordinate is equal to slope 0 times x minus a negative 4, so plus 4. Now right here, and don't be nervous about it, it just happens sometimes. 0 times both those terms, if you distribute it, what happens? You're going to get 0x plus 0 or just 0. So there's no x term here. So to solve for y, you're just going to do your inverse here. You're going to plus 5 to the other side. So y is equal to 5. And so see if this makes sense. I mean, you're going to do the opposite of x equals number, so you're just going to get a y is equal to. You're going from a vertical to a horizontal. So graphing this, think about it. 1, 2, 3, 4, 5. Now imagine a vertical line going straight through there. That's your line. So this is y is equal to 5. Crosses at 5, positive 5 on the y. Okay. And just thinking about it, there's a faster way to go. We'll see if it comes up in the near future where you could have just started with the point again, graph negative 4 or 5, and if you know you want to be a horizontal line, just graph a horizontal line through it. And that becomes your equation. Wherever it crosses the y-axis, y is equal to 5 because the slope would be 0. Okay? All right, moving on here. So we got 3/4 x minus 8 going through the origin. So you got to go through 0, 0. We're going to be perpendicular to 3/4. So right now your slope is 3/4. But we don't want to use that slope. We want to be perpendicular. So we're going to use the opposite reciprocal slope. So flip your fraction, change your sign. We're going to be using negative 4/3. So let's go back to slope intercept form. Is equal to, all right, so we're using negative 4 over 3, and we want it to go through the origin. So y is 0 is equal to slope. We want to use this one, lagging, all right, try to make that a little better looking, times the x coordinate, which is 0 plus b. Now, again, weird stuff's going to happen here, but just hang in there with it. Bringing down this side, 0. Anything times 0 over here will be 0, so plus b. So what are you going to get for a y-intercept? 0. And it's fine. If it happens, it happens. So when you do your rewrite, so y is equal to, again, the slope that we used is negative 4/3 x plus the y-intercept 0, or just negative 4/3 x. But you are done right here. Okay. And there's, going back and thinking about this graphically, easier way to be is, think about this. You know you've got to go through this point, 0, 0, and you got to be using your slope negative 4/3. So think about this. 1, 2, 3, 4, 1, 2, 3. Let's go back the other way. Instead of down 4, let's go up 4 and back to the left 3. Oops, gonna be right there. So imagine this line coming right down through here, and you wanted to write the equation of it. So y is equal to mx plus b. Think about it this way. Y is equal to, here's your slope again. Where does it cross the y? 0. And you're going to get the same answer. Okay, so definitely different ways of doing it. Here we go. Write the equation. Line is perpendicular to AB, goes through C. So let's think about this. C is located at where? Negative 3, 5. And what is the slope of AB? Looks like it's going through, looks like it's going to go up 3 over 1, or 3 over 1. All right, so let's practice that point slope again. Let's do that one. Y minus y1 equals Okay, we're going to plug in, let's see here. We want to be perpendicular, so we haven't done that yet. So what's our perpendicular slope? Flip the fraction, so we're going to go with 1 over 3, change the sign, so negative. So we're going to go with negative 1/3. We want to go through C, which is a negative 3, 5. All right, here we go. So y minus your y coordinate is going to be equal to slope, which is negative 1/3 times x minus your negative 3, so x minus a negative, so plus 3. All right, bring down this side. Hang in there with it. We're going to have to distribute. So what's negative 1/3 times x? Negative 1/3 x. Now here we go again with the fractions. Stick that over 1 if you want. Negative 1 times 3 is going to be negative 3. And on the bottom, 3 times 1 is 3. And that's going to reduce to just a negative 1. All right, so solve for y. Let's add the 5 over. Plus 5 to this side. So we got y is equal to negative 1/3 x. And 5 minus 1 is going to be bringing you back to 4. All right, there you go. And if you wanted a visual on this one, think about this. You know you're crossing at 4, and now do your slope. Negative 1 over 3 puts you this way, or going backwards, and draw that line through there. It'll totally work. All right, here we go. Next one. I like this problem. How could you use the nature of perpendicular lines to show the triangle ABC is a right triangle if given? So here's what I'll do. You got 3 points here. You got 3 sides. Let's make this easy here. Which angle do you think we should test? If I'm thinking about this, this one is the only angle that even looks right. So I'm going to test this angle. Let's test those slopes. So I'm going to use this side. Let's find the slope of this side. And now you can use the formula for slope, or you can just go visual. Okay. Let's just go visual here. That means I'd have to go up to, let me just write this over here. So I'd have to go up to, and then I'm going to have to go over to the right, 1, 2, 3, 4, 5, 6, or reducing that down to 1 over 3. So that's one side. Let's change the color up just to make it a little more interesting. Yeah. All right. All right, so for this side, see these two sides come together at that angle. So I want to see if that angle, that's the one that looks like it's 90 degrees, so I'm testing these two sides. Let's see here. All right, let's go down. Slope is equal to, let's go down 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So we went down 8. So rise is negative 8 over, we're running 2 to the right, positive 2. And that's going to reduce to basically negative 4 over 1. All right. So knowing what you know about perpendicular lines and their slopes, these two slopes are not opposite reciprocals. Not opposite reciprocals. Therefore, they are not parallel. Excuse me, not parallel. Therefore, they are not perpendicular. And now think about this. Therefore, put all this together, make a good argument. They're not opposite reciprocal slopes, so therefore they can't be perpendicular. If they can't be perpendicular, that means this angle cannot be a right angle. And for that matter, therefore, not a right triangle. That's the way you want to think about it, okay? All right, hope that helped.